Tyndale Oliver, representing FDOT, who organizes these presentations. We're going to give a couple more minutes to let a few stragglers come in, and then we'll get moving on the presentation. All right, good morning, everybody. It's about 5 after. We'll go ahead and get started here. Once again, I'm W.T. Bowman, Tyndale Oliver, and all I'm doing is organizing this thing on behalf of the FDOT. A few things first. I want to remind everybody of the Tampa Bay Traffic Safety website, where we will have the copy of this presentation as well as a recording if you need to come back and listen to it or want to review the slides at a future time. For the presentation today, we ask that you hold your questions. We will monitor the question boxes, and then we will get to the questions, any that you have, at the end of the presentation. So with that being said, today's topic is TSMO strategies, the what, why, and how. Our presenter, Dr. Alluri, is currently an assistant professor with the Department of Civil and Environmental Engineering at Florida International University. She received her doctoral degree in civil engineering from Clemson University in 2010. Within the broad area of transportation safety and traffic operations, her research has primarily focused on secondary crashes, transportation systems management and operations, the topic for today, connected vehicle technologies, safety of vulnerable users, wrong-way driving mitigation, and the application of advanced safety analysis tools. So with that introduction, I will turn this over to Dr. Alluri to begin our presentation. Thank you all.
Okay. Thank you, WT, and good morning, everyone. As WT mentioned, I'm Priyanka Alluri. I'm a faculty at Florida International University. You may actually hear my voice shivering because I am nervous when I speak with 9 people, and now I see the attendee list as 91. That actually freaks me out. But anyways, I'll try to do my best. So before I begin this presentation, I'd like to thank the team for giving me this opportunity to present on this very new and upcoming topic, which is TSMO strategies, to the group of safety professionals and traffic engineers and planners from across the state. I've been doing research, as mentioned in my bio, primarily on traffic operations and transportation safety for about 10 years. Wow, time flies. But I'm no expert. I'm just going to pretend to be one today for the next 1 hour, 30 minutes, and I'll try my best to answer your questions, and let's see how it goes. And I'd also like to thank Tracy from District 4 for giving me this opportunity for introducing me to this group, and also Peter Shu from District 7 for encouraging me to do this presentation. So in this presentation, for the next 1 hour, I'm going to talk briefly about TSMO strategies. TSMO is Transportation Systems Management and Operations. I mean, the abbreviation is so long that I just did not want to put it on the slide. And I'm going to talk about, just try to answer 3 questions. The what are TSMO strategies? Why do we need them? And how, in the sense, how can we identify or how can we think about deploying these strategies? So quickly, the outline, again, I have the what, why, and how. And just to mix things up, because it's just boring to have 3 questions, I also added the FDOT's efforts in deploying TSMO strategies. And also, since I'm a full-time researcher, if you will, I would also talk a little bit about the progress on the research front that we have been doing at FIU with other universities for the center office, and how that research could help local agencies and the districts with respect to deploying TSMO strategies, the topic of today's presentation. So the first question that we come up with is, what is TSMO? As I said, it's Transportation Systems Management and Operations. Wow, that's a mouthful. But agencies, whether it's the FDOT center office or the districts or the local agencies, primarily, especially when they're dealing with transportation, primarily have 2 goals. One is the safety and the mobility. We want to improve the safety and mobility for all road users for our entire transportation network. And in order to achieve this goal, we usually have, like, say, 3 divisions. The one on the bottom left is the Traffic Operations Division. This is the most, the traditional traffic division that focuses on traditional traffic engineering principles and practices. Some of the examples that this division may focus on are, say, signal control, signal timing, actuated signal controls, freeway operations, etc. And a relatively newer division that we come across is the ITS. ITS stands for Intelligent Transportation Systems, as we all may have already known. And ITS primarily refers to technologies. It talks about the equipment, the technologies that are out there in order to improve, again, the safety and mobility of the transportation system. By technologies, or some of the examples could be, say, red light cameras, transit signal priority, signal coordination, traveler information systems, and so on and so forth. And now, with these 2, as I would say, like the 2 divisions or the 2 legs, now we have a newer division, which is the TSMO, which is Transportation Systems Management and Operations. And it kind of like combines a little bit of traffic ops and a little bit of the ITS. And what it has is, it includes the processes, procedures, policies, and agreements to use the technology and the principles in order to improve the safety and mobility of the entire system. Instead of having these three divisions, individual divisions, as their own silos, what we or the FDOT Central Office or FHWA is aiming towards is to put all of these three under one umbrella in order to achieve the bigger goal or the bigger vision and mission of the agency, which is primarily to achieve the safety and mobility goals, that is to improve safety and mobility. So having known what TSMO stands for, I want to talk a little bit about what are TSMO strategies, or I'm sorry, I'm just trying to minimize my screen. Okay, got it. So what is the difference? I mean, TSMO strategies is kind of like a new buzzword, but what is it different? How or why is it different from the conventional or the traditional improvements? The difference is that TSMO strategies are usually, don't count me on this, but relatively cheaper compared to some of the traditional countermeasures or traditional improvements, and also they have a shorter lead time. For example, think about it. If we have I-95, we do have I-95. On I-95, if it has reached capacity, if we have to improve travel time or alleviate some congestion, the traditional approach would be to add a lane, right, or one or two lanes. That's the traditional improvement that would cost millions of dollars and would take at least a couple of years, if not more. And what happens if we add more lanes? Again, your demand increases. Again, it will be congested in the near future. Again, the vicious cycle continues, right? So on the other hand, if we want to focus on TSMO strategy, some of the strategies could be have express lanes instead of just adding multiple lanes. So, and have managed lanes or convert one or two lanes to HOV lanes, or have hard shoulder running on the side, especially only during peak hours. Those are some of the TSMO strategies that could help with the congestion relief on a particular freeway, in this case I-95, but also may not cost as much and also may have a shorter lead time. And also another issue we have, especially in urban areas, I'm from Miami, so we know that in Miami, Tampa, Orlando, in fact everywhere, we have right-of-way limitations, right? So in addition, instead of using conventional improvements that require most of the times relatively more right-of-way, we could consider adopting the TSMO strategies, which may not require as much new right-of-way as possible as needed. And we have some unconventional problems. Say, for example, if we want to improve the incident response time so that to make sure that the incident is cleared quickly, then we may not have the traditional or conventional strategies to address those problems. So in that case, again, TSMO strategies play a very crucial role. Okay. So when we look at, again, as a TSMO strategy, it is an integrated program. It is not, it does not work in a silo by itself. So it has to be integrated with the rest of the program, if you will. So what TSMO does is, TSMO offers the potential to provide an integrated program to optimize the performance of existing infrastructure through implementation of, as I said earlier, systems, processes, and services that preserve the capacity and improve safety and mobility. And most of the times, we don't have one strategy deployed. We sometimes most likely have multiple strategies deployed at the same corridor. And we may not even realize that these are TSMO strategies. For example, if you look at the first top leftmost figure, we do have express lanes and we do have dynamic message signs. These are two TSMO strategies that are deployed in order to improve or alleviate congestion on I-95. On the right, we have road rangers and also FHP of Florida Highway Patrol. Again, two different TSMO strategies in order to improve safety and alleviate congestion on a bottom left, we have the TMCs, RTMCs, the Regional Transportation Management Centers, and we also have the Traveler Information Systems 511, which also helps with alleviating traffic, congestion. And one of the good things about TSMO strategies is that it is performance-based. You look at the news, or if you look at our own transportation, the performance of the transportation network, what we see is safety and mobility are two very critical performance measure or aspects that we want to address. And so when I said TSMO is performance-based, what I mean is that we have several performance measures that we want to evaluate the performance of the TSMO strategies. And these performance measures could be divided into, say, mobility performance measures and the safety performance measures. And also, so some of the mobility performance measures, as I've listed here, are the travel time reliability, your buffer index, which I did not have it here, your total travel delays. And also, we have incident response and also incident clearance time. These are performance measures that we could use to quantify the operational benefits of TSMO strategies. When we want to look at the safety benefits of TSMO strategies, we have number of crashes. Say once the strategy is deployed, how many crashes occurred versus before and after studies, if you will, and also secondary crashes. I want to spend say 30 seconds on explaining what a secondary crash is. When an incident occurs on a freeway, it results in a traffic backup. As a result of that backup, we may experience more crashes just because of that incident. So those crashes that occurred as a result of another incident that occurred downstream we term them as secondary crashes. And it's the central offices or a traffic engineering and operations office or division's objective is to minimize these secondary crashes. So how do we minimize these secondary crashes? We need to make sure that the incident is cleared as quickly as possible. And that information is disseminated to the public saying that we have an incident downstream, so drive cautiously or detour if possible. So these are some of the strategies that we could use in order to minimize or totally eliminate secondary crashes. And as in the next slide, I will discuss that TSMO is multimodal. So some of the performance measures could also focus on the transit or pedestrians or actually even bicyclists or even metro rails. So some of the performance measures that we could use in order to quantify the benefit of TSMO strategies would be the transit on-time performance, the delay or the control delay at intersections, especially for transit vehicles, and also the number of transit stops along the study corridor. When we look at TSMO, we do not want TSMO strategies to be considered as an afterthought, but we want TSMO strategies to be as an integral component within every phase of the project development process. So here, the goal of integration of TSMO or mainstreaming, actually you'll hear a lot about the term mainstreaming. The goal of integration or mainstreaming of TSMO is that it would be at the center of all phases of the project development process. By all phases means it has to be thought or be an integral part of the planning phase, of the design phase, of the PD&D phase, and construction phase, and even operations and maintenance phase. So instead of considering TSMO as an afterthought or as just one alternative or just a checkbox that you need to consider, when you are identifying or prioritizing alternatives, we want TSMO to be a part of every alternative, if that makes sense. So that is a part and parcel of every every project or every alternative that we are considering in order to alleviate congestion or improve safety. So having said that, this is what I mean. TSMO is, and we want it to be everywhere. By everywhere, we mean at all steps in the project development process. So from planning all the way through operations. When we are looking at the planning phase, we want TSMO strategies to be considered. We want TSMO strategies to be considered as one of the potential strategies, and also how we have to look at how we can use these strategies in order to achieve the system-wide goals and also the facility-specific objectives. Say some of the objectives could be to reduce travel time or to improve travel time reliability, or to make sure that the LOS does not fall below or does not get any worse than D or E during peak hours, something like that. And also, we want you to consider TSMO while prioritizing projects as well. And in the project development phase, we want TSMO to be integrated in the concept development, design, construction, and testing. And when we come to the later phase of the project, which is operations and maintenance, in performance monitoring. Performance monitoring is by far one of the most critical components of TSMO strategies, because we want to evaluate we want to quantify the potential benefits of deploying these strategies in order to not only to sell to the upper administration, but also to sell it to the public, to say, why are we not adding one more lane, but instead converting one or two existing lanes into express lanes. So once we have accurate and reliable benefits of deploying these strategies, for example, express lanes or DMS signs, then it will be easier for us to convince the upper administration, our colleagues, and also the public on to deploy these strategies. And also, it will help to identify and expand the TSMO strategies programs to other corridors and to arterials and on an as-needed basis. So I said, I mean, when till a few years ago, I believe that you all agree with me when I say that the focus has been that we need to move vehicles as safely and as quickly as possible. But now the focus has been shifted. We have shifted considerably from saying that we need to move vehicles to we need to move people and goods. That means we want to give due consideration to the multimodalism, the multiple modes that are there that share our transportation network, if you will. So these multi-modes include the transit, pedestrians, bicyclists, rail, train, ports, airports as well, and emergency vehicles, if you will, etc. So TSMO strategies do not necessarily just focus on one mode. They are multimodal. It depends on, of course, not every strategy is multimodal, but in general, most of the strategies, they not only address one mode, but they address multiple modes. Usually it's transit and vehicles, or transit or pedestrians, or vehicles and pedestrians. So here are some of the examples. So we have bus rapid transit, we have bike lanes, airports, park and ride facilities, walkways, metro rails, metro terminals, highways, and bus stops. So these are the multimodal infrastructure that could benefit from one or more, or from at least some TSMO strategies. And I like the picture on the right, which has these e-scooters. They are scary, but they're fun to ride, I believe, but I've never ridden one. But yeah, I've seen them everywhere. Okay, now understanding the TSMO, having provided a certain background about TSMO, let me quickly talk about the FDOT's efforts and the TSMO strategies that are currently being deployed within Florida and where we are going from there. So as you all may have known, that FDOT has been a pioneer in adopting TSMO strategies to improve safety and mobility on our roadways. There are several strategies that FDOT has deployed, and here are some of them. We have the Road Ranger program, which are almost on all major freeways across the state. We have the Florida 511 program, Traveler Information System, which is increasingly being used by more people. We have the TMCs, the Regional Transportation Management Centers. We have about 11 of them across the state, and we have also 2 satellite transportation management centers, one in Tallahassee and one in Bradenton, to monitor the traffic 24/7. In most cases, it's 24/7, not all, I believe. We have variable speed limit that provides an advisory speed. It's not advisory because it's regulatory. It changes the speed limit based on the prevailing traffic conditions, so that we don't have too many stop and go, or the traffic is not volatile, so that the speeds are consistent along the corridor. It's mostly on an I-4. We also have arguably one of my favorites, because I live in Miami, the express lanes, where we have the dynamic toll pricing that provides, at least for people who can afford and who has no choice but to pay the toll, but at least they provide the reliability to reaching a destination. I mean, if I'm going for an interview, I would rather pay $2 and take the express lanes, or rather stuck in the general purpose lanes and get worried or anxious. And we do have DMS signs. These are also, if you believe it or not, one of the TSMO strategies. That is, this is to DMS signs are dynamic message signs. These are used in order to dissipate information, time-sensitive information to the traveling public, which may or may not be available through other avenues, such as the 511 system or Google Maps or Waze. So these are some of the FDOT's the TSMO strategies that are being deployed by FDOT. These are just a few. I do have a few more in the next slide. Okay, when I'm talking about FDOT's efforts, and to tell you the truth, I think I should have started with this slide. This is the 2017 TSMO Transportation Systems Management and Operations Strategic Plan that was developed, that was published in August 2017. It's a little over 2 years. Wow, time flies, because I thought it was just a few months ago, but it's actually 2 years ago. So the main vision of this strategic plan was to work towards a fatality-free and a congestion-free transportation system, which again is consistent with the goals of the FDOT and the transportation plans, which is to improve safety and mobility. So the vision is to have 0 fatalities and a congestion-free transportation system. And the mission, which is very interesting and critical for everybody, as for researchers, for me as well, is that the mission is to identify, prioritize, develop, implement, operate, maintain, and update TSMO strategies and measure their effectiveness for improved safety and mobility. So here I want to focus on 2 things. One is that there is no one-size-fits-all strategy. There is no one TSMO strategy that solves all of our problems. So every corridor, every jurisdiction has to be evaluated by itself, within itself, in order to identify the most suitable TSMO strategy. But we are not leaving it at that. We want to, by we, I mean the FDOT, the central office, it wants to measure the effectiveness of these strategies from a safety and the operational perspective. So if we are deploying a TSMO strategy, say, for example, if we are actually RAM metering is one of the strategies, which we'll talk about it later. But say, for example, yes, RAM meters or DMS signs. If we are deploying DMS signs along a corridor, say I-4, every 1 mile, and we are disseminating this information that is time sensitive to the public, what are the potential safety benefits? How many crashes, if any, are we reducing? How much, or how much are we increasing the travel time, average travel time, or how reliable is the travel time if when driving along this corridor. So measures of effectiveness is very critical in evaluating the success of the TSMO strategies. So just if we review the TSMO strategic plan, we have about 6 priority focus areas. The 6 priority focus areas for the central office, the first one is mainstreaming. What is meant by mainstreaming? Mainstreaming, as I mentioned a few minutes ago, mainstreaming, it includes incorporating TSMO elements into all transportation projects from planning all the way through design and operations and maintenance. So, and also this focus area of mainstreaming TSMO strategies is both at the statewide and at the regional level. The second one is the freeway management, which includes, as I'm sure you're all aware, that freeway management, the TSMO strategies include, say, using the Sun Guide system, the 511 system, your traffic incident management, TIM, your severe incident response vehicles, etc. What we believe is that the effective freeway management benefits even not only all just vehicles, but also all modes, including transit and EMS vehicles. And this freeway management is statewide. It is not regional. And then we have arterial management, which is usually focuses on the regular signal retiming and coordination. We have adaptive signal control technologies, ASCT, which we'll talk about it in the next few slides. We have incident corridor management. And this arterial management focuses on the regional efforts. It is not at the statewide level, it is at the regional level. And arterial management specifically focuses on all modes. It is not primarily vehicle oriented, vehicle centric, but it includes all modes, which are pedestrians, bicyclists, freight, transit, and vehicles. So these are the 3 strategies. The fourth one is the express lanes. Express lanes, as we all know, these are dynamic pricing. These could be reversible lanes in some cases, and it provides enhanced operations and also enforcement and incident management. Express lanes is also regional and interregional. The fifth one is the connected vehicles, which is at the statewide and the regional effort, which focuses on the SPAT, signal phasing and timing projects. We have the dissemination of basic safety messages information, the priorities for transit, certain vehicles, freight, emergency vehicles. All of that comes within the umbrella of connected vehicles focus area. And the last but not the least is the information systems. In this day and age, we all believe that information or data is wealth, right? So this focus area of information systems, as we call it, focuses on the Sun Guide, which is the data inventory, the data warehouse, I would say, the 511, where your information is being disseminated to the public, a data archiver, and also performance assessment tools. I mean, if we have to evaluate the performance of any strategy, for that matter, we need the data. We need as much data as possible, especially also in real time or very time sensitive information. And their enhanced information systems and data archival systems is one of the focus areas. So here are some of the TSMO strategies that I will be briefly covering in this presentation. We have I divided them into freeways and arterials. In the freeways, some of the strategies are RAM metering, DMS signs, express lanes, and road rangers. And for arterials, we have the advanced traffic management systems. Actually, I'll be focusing more on ASCT, which is adaptive signal control technology, and also the transit signal priority, the TSP. I mean, some of these strategies have been for over 10 years, or if not more, and some of these are newer. So TSMO strategies, it's just like, it may sound as if it's a new term, it's a buzzword, but in reality, some of these strategies have been deployed by FDOT for over a decade. For example, RAM meters. So let me go quickly and discuss about each of these TSMO strategies. The first one being RAM metering. So what are RAM meters? RAM meters are nothing but these are traffic signals along freeway on-ramps in order to control and regulate the frequency at which the vehicles join the freeway main line. Here, as you can see, you have a crossing, you have a main line, and you have a ramp here, on-ramp, and we have the RAM meters there, which control the number of vehicles that are entering into the freeway, as you can see here. So deployment, RAM meters are deployed on I-95 from Ives Dairy Road to Northwest 62nd Street. We have about 22 RAM meters in District 6 on both I-95 northbound and southbound, and they've been deployed, I believe, in 2000. And I think it's in 2 phases, but it's been over a year, over a decade, I believe. It's in 2008-2009 timeframe, and it has 2 major advantages. RAM meters. The first advantage is that they help manage entrance demand from the on-ramp on freeway main line, thereby preventing some traffic flow breakdowns on the main line. And the second one is these RAM meters break up the platoons of vehicles on the ramp by controlling the rate at which the vehicles enter the main line from the on-ramp. So because of these two, because of how the RAM meters function, we believe that it improves the safety as well as the mobility. As one of the research, as part of a research project, of an ongoing research project that I'll talk in a few minutes, we are evaluating the safety and operational benefit of RAM meters, and we are using buffer index as one of the performance measures to measure the mobility performance of RAM meters. And we have seen significant improvement. I don't want to name numbers because I don't want to give numbers yet because it's a preliminary results, and the numbers might change a little bit, but and they have not been approved by the central office, and hence I'm not giving the numbers. But we have seen significant increase in improvement in buffer index, especially when we are deploying RAM meters, especially during peak. Of course, RAM meters are deployed during peak hours. So the second strategy, we call it strategy, but it's just the DMS science, is that these DMS signs, the dynamic message signs, these are programmable electronic signs that are used for disseminating real-time, time-sensitive information to road users. By time-sensitive information, information could include travel times to a certain destination or to an exit or to the next major attraction, if you will, information about road closures, information about incidents that are ahead, information about adverse weather like rain, fog, poor visibility, or even amber alerts. All that information that is time sensitive could be displayed and disseminated to the traveling public in real time. And of course, some of this information could also be received through other navigation applications such as Google Maps, but still DMS play a critical role in disseminating this information to the traveling public. And you know what? DMSs are everywhere, almost everywhere. We have roughly about 869, I just round it up. We have about 900 DMSs displaying messages on major roadways. And these are most often operational 24/7 to convey time-sensitive information to motorists. And usually when they do not convey any time-sensitive information, they do provide information that is good to know, in the sense that click it or ticket or buckle up, put your child in a seat belt, don't drink and drive, don't drive distracted, etc. So but mostly DMS signs are along freeways, And again, as part of this ongoing project with the central office, we are also evaluating the safety and mobility performance of DMS signs. And interestingly, we are using the drops in the speeds by drivers when they see the message on the DMS, using real-time speed data that we collected from the detectors. So that is going to be some interesting results. Advantages of DMS signs, as I said earlier, it minimizes travel delays and it reduces secondary crashes, because we actually found this in our ongoing study, that what we found was, like, when the information about incident ahead, use caution, or crash ahead, left lane blocked, use caution, when that information was displayed on the DMS signs, drivers become more cautious and they drive more carefully as a result, and they become more vigilant, and hence they may actually have lesser likelihood of ending up in another crash. So that is results in reduced secondary crashes. It will also minimize travel delays and enable fast and appropriate response to incidents. Also, SS motorists make informed routing decisions. Say, if I'm going on I-95 and Turnpike, both run parallel, if there is an incident on Turnpike, and if I get this information on my DMS sign well in advance, I could reroute and go to I-95, which would save time and also reduce the possibility of secondary crashes. So that's with the DMS. And the next one, what I'm talking about, is the express lanes. Express lanes are managed toll lanes separated from general purpose lanes or general toll lanes within a freeway facility. And we call these express lanes as, just for fun, not actually for fun, we use it as a real term, as a freeway within a freeway. So a deployment, believe it or not, we have quite a few projects that are either under construction or in the planning or the design phase. In operation, we have about 62 miles of express lanes, mostly in South Florida, I believe. We have I-95, 595, 75, and the Veterans Expressway. And under construction, we have about 100 miles, mostly on Turnpike, 95 to 75. I'm just reading it from the list here. 826. You can read it as well. I-4 and 275. In the planning and the design phase, we have about 300 miles of express lanes. So advantages, again, express lanes, these reduce the overall traffic congestion and provide a safe and predictable trip in terms of travel time. And it also increases the capacity of the highway. Again, as part of this ongoing project, we are evaluating the safety benefits and the mobility benefits of express lanes. And we found that when the express lanes are operational, the mobility or the travel time, reliability, again, we use buffer index for the entire corridor when the express lanes were open, improved compared to the times when they were closed. So that gives a positive note to saying that these express lanes provide improved mobility by reducing congestion. Okay, so the next one is the road rangers, and these are agencies or personnel that patrol freeways for incidents, and they provide free assistance to motorists, and it is considered as one of the incident management strategies. Deployment, it is road rangers are deployed on almost all major freeways in Florida, and it has two major advantages, I would call them. One is with respect to the assistance, and they increase safety at incident scenes. And when we are looking at incident response, they help with reducing the incident duration. So they help with clearing the incident as quickly as possible. So usually, in several cases, road rangers are usually the first ones to respond and to be at the incident site, and as a result, speed up the incident clearance time. And we found that when road rangers are involved, incidents are cleared much faster compared to the incidents when road rangers were not involved. Okay, so far we've looked at tram meters, DMS signs, road rangers, and express lanes. Those are all the TSMO strategies along freeways. And we do have quite a few, or in this class, I'm just going to talk about two TSMO strategies on arterials. The first strategy that I'm going to talk about is the adaptive signal control technology. And it is a traffic management strategy that optimizes signal timing based on the real-time traffic demand. And advantages, how it works, it's, at a very high level, how it works is we have sensors that monitor traffic, and depending on that, they change the signal timing plan, and then, and the process continues. And the advantages are both in terms of safety and mobility. In terms of mobility, I sound as if I'm repeating myself, but this is the true. For almost all TSMO strategies, they have similar advantages. In terms of safety, you improve safety by reducing crashes. In terms of mobility, you improve traffic flow, reduce delay, and improve travel time reliability. Another strategy, we call it TSMO strategy, but it is a TSMO strategy, which is transit signal priority, where we give priority to the transit vehicles, for example, buses, when they reach an intersection, so that they get green as quickly as practical, so that they do not have to wait at a signal for longer time. And the TSP has been deployed in several corridors in the state of Florida, not just one, several corridors. And this is just one of the corridors in Miami. I think it's about 10 to 12 miles. And we are evaluating the safety and operational performance of this corridor in order to quantify the benefits of transit signal priority. When we are quantifying the benefits, we are not only focusing on the performance of the buses, but also the performance of all vehicles along the corridor. And we found that TSP not only improves the travel time or the average speed and reduces the delays for buses, but it also improves the travel time and reduces the delays for all vehicles along the study corridor, not just transit. So in other words, it's a win-win for both transit and vehicles. Okay, I already mentioned this, but the advantages are reduced transit delay, encourage use of transit, and improve overall performance of the corridor. Again, just to reiterate, it improves travel time. What we found from our analysis was that it improves travel time not only for buses, but for all other vehicles as well. So we are at 10:48, and I have like 10 more slides. I will quickly go through them just so that I have some closure. So when we think about, again, TSMO strategies, I hope we all can agree that we can't build our way out of congestion. So we need to find a way to efficiently and effectively use the existing transportation infrastructure to the maximum extent possible. So this TSMO strategies will help in preserving the capacity and improving the security and improving the safety. So in addition to the traditional safety countermeasures, we need to look at other strategies that could also improve safety along our corridor. And travel time reliability is a very crucial component, since that is one way of measuring the operational performance of our transportation network. And TSMO strategies will help improve travel time reliability, or in this case, is reliability of the entire transportation system. And TSMO strategies, just to reiterate, address congestion, they improve mobility, they improve level of service. And just to throw in some numbers there, on average, the capacity expansion, when you're expanding the capacity, it provides a 2:1 return on investment. The return on investment is 2 times. But on the other hand, when we are using the capacity management, using TSMO strategies, we are not improving, we are not adding more lanes, but just we are trying to find an efficient way of managing what we already have using TSMO strategies, And we found, not we means I didn't do it, it's just a research from other studies. What they found was that the return on investment for TSMO strategies is 9 times. And this slide, it's mostly what we already know, what we already discussed, but it says increasing the capacity is constrained by cost, and congestion has adverse impacts. By adverse impacts, I want to focus on 4 things. We've been talking about 2, the safety and mobility, but we do have the other 2 not so obviously visible aspects, which are environment and also the economic development. So these are the 4 goals I would call: the safety, mobility, economic development, and environment. All TSMO strategies help improve all these 4 goals. And in general, the objective is to better manage and operate a transportation system. And TSMO strategies, the way I see it, are for specific time periods of the day. Say, for example, we can deploy these strategies, say, during adverse weather conditions, or when you have just construction or work zones going on, or when we are doing hurricane evacuations. Say, for example, we could use reversible lanes during hurricane evacuations, or you could use hard shoulder running, and we could disseminate the information via dynamic message signs, in addition to other avenues, which include the Waze and 511. So again, we already discussed about this, but just to reiterate, why do we need to use TSMO strategies? Because we, as I said, we can't build ourselves out of congestion. That's one thing. And another thing is, like, we don't have enough money to continue to invest in these high-cost countermeasures or strategies. So we need to find a way to optimize the performance of our existing facilities. So with limited funds and with the use of leveraging the technology, the advances in technology, we can develop solutions to address the congestion issues. And also the changing needs and expectations of the traveling public. As a road user, as a driver, I want to have some sort of travel time reliability so that I can pick my son up from daycare on time, or I can be attend a meeting on time. So travel time reliability and expectations are just increasing, not only from the public officials, but also from the general public. And also, now that not all congestion is the same. We have recurring congestion, which is only or especially or primarily during peak hours. And we have non-recurring congestion, which is because of incidents, crashes, or adverse weather, or work zones, or special events. So we can't traditional strategies can only, to an extent, primarily can address recurring congestion, but not non-recurring congestion, which is time sensitive, or which is dependent on several other factors, such as the time of the day, the season of the year. So it's not permanent. So having a better understanding of the causes and the types of congestion, TSMO strategies can help with alleviating these non-recurring congestion. And TSMO strategies, just to reiterate, as I mentioned, can address the 4 goals: the safety, mobility, we have economic development, and the environment. And these strategies improve multimodal traffic management, traveler information, traffic incident management, transportation demand management, and it also has environmental benefits. So circling back and coming back to Florida, so what is the goal of TSMO strategies, of deploying TSMO strategies in Florida? The major goal is to apply these initiatives in districts and statewide to better understand and apply these TSMO strategies, and also to mainstream TSMO so that TSMO can be implemented in all phases of the project development process, planning all the way through maintenance and operations. And here are some of the functional areas that we want, or the central office wants TSMO to be mainstreamed into, if you will. And measures, as I said earlier, one of the major interests for the central office and one of the research projects that I'm working on is to quantify the benefits of TSMO strategies. By benefits, we want to categorize them into safety and mobility. So we have both quantify the safety and mobility benefits. So why do we need to quantify? Because to better sell the idea, that we like it or not, we need to sell these ideas both to the upper administration and to the general public, right? So it is to better sell the idea of TSMO strategies to both the upper administration and to the public. And we need to find a way to accurately and consistently evaluate the safety and mobility performance of these strategies. Again, as I said, there is no one size fits all. We cannot say that this strategy, this specific TSMO strategy is applicable or suitable for or to help solve all problems. No. So, and also there is no one performance measure that can quantify the benefits. So we have a wide range of performance measures or the outcomes, if you will, to choose from in order to better accurately and reliably assess the performance of strategies. Some of the outcome measures are customer satisfaction, which is very subjective, but extent of congestion, the incident duration, incident clearance time, the traffic delay, buffer index, the average speeds, the reduction in speeds compared or the increase in speeds, increase in throughput, the travel time, reduction in travel time, and how the buffer index, which is a measure for the travel time reliability. So how do you select TSMO strategy for deployment? The first and the major goal or first step is to have a very clear understanding of the existing congestion or the safety problem. And once we have the problem, then we need to look at the location and the extent of the problem. Is the problem system-wide or is it corridor-specific? And depending on that, the next step would be to identify the affected road users. So who are the road users that are being affected? Is it only the vehicles, or is it vehicles and transit, or how is it impacting emergency vehicles? Or how does the pedestrian, if it is an arterials, how does pedestrians and bicyclists considered in this mix? And then identify the stakeholders involved. And once we do that, the next step is how do you assess viable alternatives? Return on investment or benefit to cost analysis is one approach. And this is crucial because we have several alternatives even in terms of TSMO strategy. So which one is better? So we need to identify all the relevant strategies and then identify the constraints and criteria, followed by the benefit cost analysis, and then finally come up with the optimum solution. Okay, I don't want to take too much time, so I'll wrap up in the next 5 minutes. Please bear with me. So how do we integrate TSMO and ITS? I think in the first couple of slides, I talked about the three divisions, the traffic operations, the ITS, and the TSMO. And ITS focuses primarily on the technology, while the TSMO focuses on the processes and procedures. So although not every TSMO strategy requires ITS, it's fair to say that ITS plays a major role or is a major component of several TSMO strategies. So how do we do it? We collect data, we research available and new technologies that are out there, and then communicate with the stakeholders, and then find a way to integrate the ITS technologies with the TSMO strategy in order to implement the strategy. And all TSMO strategies, irrespective of the size and scale, requires coordination of multiple agencies and departments. So coordination has to be at all levels of the program, from planning, concept development, design, operations, and maintenance. And how do you monitor performance? Again, I'm circling back to, and just want to reiterate that monitoring the performance of these strategies is very critical. Is in fact, I would say one of the most critical aspects, because they have to be monitored to assess whether they achieve the intended goal. Whether with these strategies, have we improved safety, or God forbid, have we induced have we made the network less safe? Or have we inadvertently increased congestion? So how do we do it? We need to collect the data first, and then we need to select suitable performance measures. As I mentioned in my earlier slides, there are several performance measures that could be used in order to quantify the benefits, the safety and the mobility benefits of TSMO strategies. So do we use average travel time, or do you use travel time reliability? Do you use buffer index, or do you use planning index? Do you use reduction in speeds, or do you use variance in speeds? So we have to identify the most suitable performance measure and then develop a methodology and then apply the methodology in order to estimate the performance, then generate performance reports, and then depending on that, tweak the strategy to see if it could be deployed at other locations, or just to evaluate how good or not so good the strategy has been. And that is a whirlwind tour of my presentation, but I do have a couple of slides on the progress on the research front. And thanks to the effort, to the support from the FDOT Center Office and the Research Center, I've been fortunate enough to work on a few research projects, primarily focusing on TSMO. One of the projects, this was done actually a couple of, not exactly 2 years, but about 1.5 years ago. Time flies. This project, this is with University of North Florida, both of us, and with Larry Hagan. I hope he's on the call, or maybe not. In this project, what we focused on is to evaluate the project processes to help mainstream TSMO in various aspects of the project development process. And we helped develop some of the guidelines, and some of the work that went into the strategic plan came from this research project. And I am FIU, myself and Dr. Sando from University of North Florida. We are working on an ongoing research project with the central office, which is to quantify the safety and mobility benefits of TSMO strategies. And Raj Ponaluri from the central office and Tracy from District 4 are the project managers on the for this project, and they've been very supportive of the project, and I hope we could deliver results that are readily applicable and adoptable by the districts and the local agencies. So under this contract right now, we are evaluating these previous strategies and the arterial strategies. These are all the strategies that we have been talking about. RAM meters, DMS signs, express lanes and road rangers. In arterials, we have ASCT, adaptive signal control technology, and the transit signal priority. So under this contract, we are, as I again said, quantifying the mobility and safety benefits of TSMO strategies. And we are also developing a TSMO strategy assessment tool to help the agencies select one strategy over the other, or to kind of estimate the potential benefits of deploying a particular strategy. So we may not go all the way to calculate the benefit cost for a strategy, because it all depends on the corridor and the study location, but we will develop a tool, mostly Excel based, which will provide us information about what could be the potential benefits if this strategy is deployed at a particular location. And we are also going to develop one-page summaries for each strategy with a background, with an example test deployment location, and the potential safety and mobility benefits that strategy would result in. And the deadline for completing this project is March 2020. And we are 70, 80, 60, 70, I don't know if my Tracy is on the line, but we'll get there. We'll finish it by the deadline, no matter what. But anyways, so that is the project. Please be on the lookout for this final report, and for these tools that will help local agencies and the districts to identify and prioritize TSMO strategies that could be used for deployment. And that is the end of my presentation, I believe. Yes, that is all I have for you today. And I hope I gave you some good information to think about. And if you have any questions or comments, please feel free to email me. I'm available 24/7. So yeah, feel free to shoot me an email or give me a call anytime. Thank you so much. And
thank you, Dr. O'Leary. We've got a few questions in our question module that I'm gonna read out and see if we can get some answers or information on. I think we have 5 or 6. So the first 2 are cosmetic. There was a question about being unable to see the handouts portion. So if you click on view at the top of your GoToWebinar screen, you should be able to see a checkbox for handouts, and that should open the handout portion. If you can't get to that, the handouts are available on TampaBayTrafficSafety.com. Look for the link to the Academy. And you can always email me and I can help get you what you need. Secondly, we had the title mixed up in the PDH request form. That has since been fixed on both the website and in the handout module. Okay, so the first question we had was, outside of FHWA and state DOTs, how common is the term TSMO? Would that be comparable to saying smart streets or smart signals, especially when communicating with the public?
I believe that TSMO is being increasingly used by both FDOT and FHWA. The only difference is that FHWA is kind of like dropping the ampersand in between, and they're just calling TSMO TSMO, while in FDOT and I still use TSM and O. So that is the only difference between the two. But I think it is maybe with time in the next few months or years, it will be like, as common as ITS. That answers the question.
How would you explain it to, if you're working with private citizens, say in a public meeting or something, because TSMO might be a little above them. Do you like the term smart streets or smart signals?
Yes and no. The smart cities and smart streets and smart signals might not might not cover all strategies that are part of the TSMO. Say, for example, if we are using express lanes, right? So it's not signals and it's not streets. So it's difficult. But I think we can change the terms to cater to the audience. Definitely, yes.
Thank you. We had a question. It was back on one of your earlier slides, to please expand a little bit and clarify what mainstreaming is.
Okay. By mainstreaming, what I mean is that we want the TSMO to be thought about, to be considered at different stages of the process, of the project development process, from the planning all the way through operations. So instead of considering TSMO as an afterthought or considering TSMO strategy as one of the alternatives at the end, we want TSMO to be considered in every alternative if possible, if you are evaluating multiple alternatives, and also not think about it at the end when you're actually designing or implementing, but at the planning phase. So if we want to say deploy DMS signs along the corridor, that could be in addition to other strategies that you are considering. So have that as part of the from the first get-go, from the planning phase. That makes sense.
Yeah, that makes perfect sense to have it incorporated, just like various other items of our project development have TSMO be considered up front. Okay. Let's see. Are you aware of other studies that show the reduction in congestion when adding a general purpose lane? I believe you mentioned this, but adding a general purpose lane versus using an extra widening to add something like an HOV lane? So I think the question is there any data that says the benefits of an HOV lane as compared to just adding a general purpose lane?
That's a good question. On top of my head, I don't remember if there is a study that specifically addresses your concept of adding a general purpose lane versus adding an HOV lane. But as part of our ongoing research effort, what we did was we compared the performance of, say, 8 lanes of general purpose lanes where when the express lanes are closed versus the 8 lanes of general purpose lanes when the express lanes are open. And we found that when the express lanes are open, the travel time reliability improved. The reliability improved on both express lanes and general purpose lanes.
Okay. Okay. So here's a question so the focus of TSMO is to increase the efficiency of the system. So would tools like travel demand management and BRT also be considered strategies under that?
Yes, sir. Yes.
Yeah.
I mean, BRTs and TSP, freight signal priority, yes. Yes, all of these are considered as the strategies.
Okay. This is a good question because a lot of our audience work with or work for or represent local agencies. Does FDOT have a plan to engage local agencies to deploy these strategies or partner in these strategies on a more local street system? And these are my words. The second part is a lot of these strategies are big. They're freeways, they're arterials. And I think the question here is how can we get those to trickle down to also the local arterial level, maybe not even the state maintained roads?
That's a very good question, and I think that's above my pay grade.
Okay.
But I mean, just from as a researcher, I mean, I believe that FDOT would be. I mean, again, please don't call me on that. This is just me talking.
Sure.
I think FDOT would want all agencies to consider TSMO strategies, but I am not. I don't think I'm qualified enough to talk about the logistics of how it could be done. Yeah, the way I see it is like as a road user, when I'm driving, I don't really know whether I'm driving on a state road or on a local road, right? I mean, I expect that the safety and the mobility to be at least on par with the state roads throughout my commute. But I could be totally wrong and totally off. So sorry, sir, I can't answer that question because I don't know.
No, that's fine. We have a lot of FDOT people on these calls, so I'm sure that the locals will have this in their mind and reach out to them for ways to engage with FDOT and partner with them in strategies, reviews, implementation. So, and let's see here. There was a question about how are mobility factors going to be applied? I believe that was on one of your end slides. Some of the research you're doing.
Yes. So let me see. Mobility, okay, we came up with this term actually. We came up with the term called, this is the term actually. We came up with the term called mobility enhancement factors. So say for example, for RAM meters, our performance measure for mobility is buffer index. So what we are saying is when the LOS is C or D, if we have the RAM meters, it will improve your buffer index by 20%. That is how we are going to finally boil it down to. And when your level of service is E or F, your buffer index is, if you have RAM meters turned on, your buffer index would improve by X%. So the next step would be for us to find a way to convert that percentage increase or reduction or improvement in the performance measure, in this case buffer index, to monetary value in order to help with the benefit cost. And buffer index is just one of the performance measures. But for dynamic message signs, what we were using is the travel speed. So has the speed increased if a certain type of information was displayed on the signs, and if it's improved by how much? Did it go from 60 to 63 or 60 to 54? Stuff like that. But that's a very good question to see how we can convert these benefits into costs. I mean, it's the same case with crash modification factors, right? Say, for example, if you have crash modification factors, we are saying that if you deploy this strategy, your CMF or crash modification factor is 0.9. That means it results in a 10% reduction in crashes. And we found a way to convert that 10% reduction in crashes into a monetary value. So similarly, we'll have to find a way to do that. But at least when we are comparing two strategies or two scenarios, saying that, okay, This strategy is saying that it will potentially improve buffer index by 20%, versus this one, which is potentially improving buffer index by 10%. At least you have something to go by. And to tell you the truth, this is the very first project in the entire country. I don't think I'm wrong to even attempt to quantify the safety and mobility benefits of these strategies. I mean, there are a few studies here and there that just looked at one aspect of a strategy, but this is the most comprehensive study that anybody has ever done. So that's all.
Excellent. Very good. I'll be anxious to see it. We have one more question right now. If anybody else wants to get a question in, please do so. This is the last one I have. And the question is specific to managed lanes. Beyond raising the price, are there other strategies to implement when managed lanes become congested?
Unfortunately, to the best of my knowledge, no. Because the way managed lanes are managed is with pricing. So it's like the objective is to maintain a certain level of service or certain travel speed along the managed lanes. So the only way to control or to limit the number of people who are entering the facility is by increasing the toll price. So we have to, I don't want to use the word play, but we have to change the toll price in response to the demand. The higher the demand, the more the toll price, so that fewer people will enter, so that the travel speeds are consistent and above, at a LOS A or B. So I think at this point, I don't think we have any other way to maintain speeds on managed lanes besides using toll amounts.
Okay. Well, that appears to be the last question I had. Dr. O'Leary, thank you very much. All the attendees, thank you. A reminder that you can download PDH request, you can download this presentation, and it will also be uploaded a recording to tampabaytrafficsafety.com. My contact information is in the invite and the reminder. So if you need something or want to reach out to me or Dr. O'Leary, feel free to contact us. But with that, thanks again to everybody, and especially thank you, Dr. O'Leary.
Thank you so much, sir.
Thank you.
Okay. Bye.